Hello everyone, we are from Group 2 and in this video we will present our mini project which is Supervised Learning Mini Project. We looked at the dataset and as you can see it contains 4 features: sepal length, sepal width, petal length and petal width, and the target variable species. Our goal is to predict the species based on these features. And the first thing we did was to check the first row to ensure that the data was structured as expected. Next, we split our data to prepare for the training and testing phases. We used a simple random sampling method to create a training set with 70% of the data and testing set with remaining 30%. This is vital because it prevents our model from simply memorizing the training data. We then confirmed our split was successful with 105 rows for training and 45 for testing. We also verified that the distribution of species was balanced in both sets, ensuring our models get a fair representation of each class. Now, I will pass it to the next person who will explain on how we build our models.
Thanks, Alia. Next, we began our model building. So we wanted to compare 3 distinct approaches to the classifications. So let's start with our first model, the decision tree. So we used the RPart package to build our decision tree. This model works by creating a series of yes-no decisions to classify the data. Notice the output on the screen. It looks like a flowchart. For instance, the very first decision based on petal length. If the petal length less than 2.45, it immediately classifies the flower as Sentosa with 100% certainty. And then next, we built a linear discriminant analysis or LDA model. This is more traditional statistical method that finds a linear combination of features to separate the classes. The model summary shows up the group means and the coefficient of linear discriminants. This tells us how the model is mathematically separating the species. And then last model, which is a support vector machine, SVM, are all about finding the optimal hyperlane or decision boundary. That's the best separate classes. We use a radial kernel, which is a key feature that allows the SVM to handle nonlinear data and find complex boundaries. The output here gives us a quick summary of the model parameters and the numbers of support vectors it used.
Thank you, Ali. We now move on to the model evaluation phase. Let's start with decision tree. The confusion matrix compares the predicted species to the actual species. Ideally, all numbers will be along the diagonal. In our case, all 14 Sentosa flowers were correctly classified. For versicolor, all 18 were correct and only one Virginica was misclassified as versicolor. This gave us an accuracy of 97.78%. Next, the LDA model produced almost identical results. Sentosa was perfectly classified and only versicolor was misclassified as Virginica, achieving the same overall accuracy of 97.78%. Finally, the SVM model also achieved 97.78% of accuracy with only one error. The confusion matrix showed perfectly classification for Sentosa flower, very high accuracy of versicolor, and only one misclassified Virginica. Across all models, Sentosa was the easiest to classify due to its distinct features, while most errors occurred between versicolor and Virginica due to their natural similarity. That's all from me. I will pass on to the next person.
Thank you, Salwa. I will summarize from our model evaluation. We found several key insights much about our model's performance. While all 3 models, which is decision tree, LDA, and SVM, are performed exceptionally well, the SVM stands out as particularly powerful. SVM separate overlap grouping classes using optimal boundaries and handle non-linear patterns with a radical kernel. Key features like pattern length and width were used effectively. SVM achieved near perfect classification with a kappa of 0.9664 and balanced accuracy of 97 to 100%, showing consistent and reliable performance. From our result, we gained three key insights, which is all model achieved 97.78% accuracy, show the iris dataset is easy to classify. Second is the dataset is well separated, allowing clear decision boundaries. And last is no single model is superior or performs similarly, providing flexibility in model choice. In conclusion, our project was a great success. It shows how robust supervised learning algorithms can be effectively applied to solve classification problems with high accuracy. Thank you. That's all from us.